Hello. Okay, guys, we are live. So, hello everyone, and in this video, we'll be learning about hash table using JavaScript. And hash table is a very popular term. You can also call it a hash map or a dictionary, and it's actually used in a lot of programming language, not just only JavaScript. This is a very common term used in other languages also. So, why is it important to learn hash table? Because it's actually based on the concept of key value pairs, which we have covered in objects also. Okay, the same concept is covered in objects also, but there are some limitations. Why should you use hash tables instead of objects for a bigger purpose? Okay, for basic purposes you can actually use objects. It's fine, it's great, like for normal showing data of any user using objects, it's fine. But if you have a lot of data in a single object, so it becomes very difficult to actually find the exact things. Okay, so it becomes very difficult. So for those purposes we actually use hash tables. So basically it's similar to objects but a little bit more modified version, and we actually create tables inside any hash table. Okay, so we'll see that. All right, so before moving on, in the live chat we have a course spec. Okay, just a minute. Hmm. So in the live chat, you can see that we have a course specifically designed for data structures and algorithm using JavaScript. So you can go to that link or you can check out the description. So this is a very great course for those who want to learn data structures and algorithms in JavaScript, and this is a paid course by the way, so you can actually check out the details of this course. If you want to learn these things, then definitely you can check out this. And this course is actually taught by Sandeep sir, who's the founder and CEO of Geeks for Geeks. So he has a very great teaching experience, and you can refer this course, it's a great one. All right, so now we can continue. So first of all, let's define what is hash table. Okay, then we'll continue more with the theory part, then we'll continue with the coding part. Hi Aman, I'm fine, how are you? Okay, so what is hash table? A hash table is also known as a hash map or dictionary, which I told you right now, and it is a data structure in computer science that organizes and stores data in key value pairs. So, like if you want to store something in key value pair, like my name is Harshal Jain, my age is 25, my gender is male, something like this. So you can actually use objects for that, but for a broader purpose, you might be using hash tables later on. Okay, so it is actually used to organize and store data in key value pairs. So it uses a hash function to convert keys into numerical indexes. Okay, so you can actually say that suppose your key name is hello world. Okay, or you can say your key name is name, first name, last name, or suppose your key name is hello world. Okay, I'm just talking about name, not the value. Okay, hello world, it can have some different value. So objects actually had some limitation, like we can't identify things very easily. Okay, but in hash table we actually convert a key into a unique integer. okay, into a unique integer. So suppose I converted first name to 25, something like that. Okay, so what will happen is I am easily able to identify what's available in 25. Okay, what's available in 25 if I have thousands of things in a single object. So it's very easy to identify that because it's a number now. Okay, so that's why we use hash table. So it allows efficient storage and retrieval of values. So suppose you want to get efficient data, like if you have a lot of key value pairs in a single object and you want to get them efficiently fast enough, so you will be using hash tables. So let's take an example of how hash tables are better than objects. Okay, we have covered objects in the previous video, so you can check out what's the use of object and why were we actually using it. So objects are great, and for normal purposes we must use objects because they are easier and to the point, and they don't require much quicker data retrieval because data is very limited, so you can easily find things in a very less time. So you don't need uh, objects for bigger for smaller so you don't need objects for bigger amount of data. You need objects for smaller amount of data. You need hash tables for bigger amount of data. Okay, so let's give an example. So imagine you have a box of, let's say you have a box of colored blocks. Okay, colored blocks. So each block has a unique shape. It might be a circle or it might be a square. Okay, so to organize these blocks, we actually want to organize these blocks because we want to find which is the red colored circle, okay, which is the blue colored square, something like this. Our purpose is something like this. So suppose there are lots of shapes and lots of colors, so how would you be able to find the specific shape and specific color? It will become a little bit difficult in objects because you need to compare it one by one, and it's time consuming, and it can be done by a normal human being, but it's still a time consuming task. Okay, so as for the computer also. Okay, so if we use objects, so with objects we can label each block with a unique name like circle 1, circle 2, circle 3, something like this. Okay, and square 1, square 2, square 3, something like this. Okay, so we can put these blocks inside the box remembering their name. Okay, suppose our object is a box, and we'll be remembering this name, this blue colored circle. I'll just name it something like circle 1. This red colored circle will be circle 2, something like this. So you can search through the box by some key value pairs. So by checking each name of the key and getting its value. Okay, so you find one by what you are looking for. So it's easy when you have limited number of key value pairs. It's very easy to find. Like if you have only 3 circles, you have only 4 squares, it's fine to judge what's the difference between them by their name and value. But if you have a lot of things, then there will be problematic because we are limited with names somehow. Okay, so like usually we are naming it like names like circle 1, circle 2, circle 3, square 1, square 2, square 3, or you can also more define it for a better purpose, but it still becomes difficult. Okay, usually in a large amount of key value pairs there are also a lot of common names with a little bit of difference. So it's still difficult in an object to find the exact value very easily. Okay, so sometimes we might even forget what's the exact name which we have provided. So it's a lot time consuming. Okay, and it sometimes causes a lot of confusions, and a lot of things happen with objects. Okay, if you have a lot of values. So hi Singostic, how are you? So this was the problem with objects. Now, why are we using hash tables? Hash tables are basically used for solving this problem. Okay, how are we solving this problem? So instead of relying on the names like circle 1, circle 2, circle 3, square 1, square 2, square 3, we just look at the shape, okay, and put it into a corresponding compartment. Okay, suppose there are 3 shapes: circle, square, and triangle. So what we do is we actually create three compartments: circle, square, and triangle. Inside this, we can also define it further. We can also create sub compartments of that also, like a blue circle, blue colored circle can be of different kinds of blue, light blue, dark blue, something like this. So suppose we have a circle compartment. Here we'll be storing all colors of circle which are available with their specific names. Similarly square, similarly triangle. So it becomes a little bit more easier to actually find things because we are creating categories. Okay, we are creating categories, so we can easily go to the circle folder and then we can find that what circle we want to find. Okay, so this is a very basic usage. And when you receive a new block, you look at its shape and put it into a corresponding compartment. Like suppose I want to put this specific block into a specific table. Suppose we have a hash table. How are we putting this block into a hash table? What's the method? So we are simply identifying its shape. It's a circle. So in our hash table we'll be finding the category. Either it is a circle, either it is a square, either it is a triangle. So it's a circle, so we'll be putting this into a circle compartment. Inside this you can define the key value pairs. Okay, similarly for other shapes. So this is only the single use of hash table. We can actually use hash tables for a lot of different examples for different purposes. This is a very basic example which I gave you for hash tables. Okay, so instead of relying, we can actually use hash table and organize the blocks in that way. So when you need to find a block later, right now we just kept a circle inside the circle compartment, so we can actually go directly to the compartment labeled with the shape, that is circle shape, and which you are looking for, and we can quickly find the block which we need because we have categorized things. So hash tables make it easier to find the specific block because you don't need to remember individual names or search through all the blocks. You can go to that specific category, then you can create more subcategories and something like that. Okay, so you can go directly to the right compartment and find the block you want without much effort. We'll see that how we are actually implementing this in a better way. So now we'll see that what's the purpose of using hash tables. Let's see the purpose. So like where is hash tables used? Where are hash tables used? Like for normal data retrieval, we usually use objects, but where are hash tables used? So the purpose of hash table is actually to provide fast and efficient lookups for operations. If you have a large amount of data, you will be using hash tables. So by using a hash function to compute an index for each key, okay, we actually convert a key into any index. Suppose key is Harshal, okay, I can convert it to something like 54. Okay, you can see that I converted the string into an integer, into an index, okay, something like that. So we'll be converting that using a hash function which we'll be creating. So hash table minimize the time required to store and retrieve values associated with specific keys, because we are actually not dealing with strings, we are actually dealing with indexes, that is integers. So it's easier to find things that way. Okay, so this makes hash tables ideal for scenarios where the quick access of data is crucial, such as number one, caching. We use hash tables in caching. So hash tables are commonly used in caching systems to store recently accessed data. You might have heard about caching. So second usage is database indexing. So hash tables are employed in database systems to actually accelerate searching and indexing operations. So number three is associative arrays. This is not so common term, okay, so you can just ignore this, but it's actually uses hash tables. So hash tables serve as a foundation for associative arrays in many programming languages. Okay, so now what we'll do is we'll be writing a simple program and we'll be understanding why are we using hash tables. Okay, you might find it similar to objects, but it's one edge more above than objects. Okay, so now let's start with the coding part. Alright, so here we'll be creating our lecture 5 because this is lecture 5, right? So lecture 5, fine. Okay, so let's open this with VS Code. So if you haven't installed VS Code and Node.js properly, please watch my previous first or second video for the specific playlist. Then you'll find how I'm actually running this code. Okay, so here you can create a very basic file such as script1.js, something like this. Okay, so we have created a very basic file. Now we'll be actually understanding what's it actually doing with. Okay, so now we'll be understanding what is actually hash table by creating a very simple function. So right now I'm just creating a hash function which actually converts a string to an index. Okay, we'll be creating a hash function. So I'll just say this, you can create an arrow function also. So hash function. Okay, hash function. Inside this we have some we'll be providing the key, that is, suppose my key name is Harshal. Okay, and then we'll be also providing hash table size, because it's important to decide what's the size of table. Your size can be 100, your size can be 250, something like this. Okay, so hash table and size, hash table size. So these two parameters will be given to this function whenever we call this function. Okay, so now suppose we have these parameters, so we'll be just creating a variable. You just need to write it this way. You can actually use a different number, it won't cause much difference, but as a beginner you can start with 0. Okay, instead of this, a lot of people start with prime numbers. Suppose you can start with 17, something like this, but for now we'll be just starting with 0, because we just need to understand things that way. Okay, so I've just created a simple variable, let hash equal 0. Now first I'll be writing a code, then I'll be explaining this code. Okay, so I'll say that let's create a for loop, and this for loop will actually run till the length of key. Suppose the key is Harshal. Harshal. So what's the length of Harshal? Harshal. Okay, that's my name. So 7. Okay, so 7 is the length. So we are actually trying to traverse this string. So in this for loop, what we'll do is we are actually traversing this string. Okay, so we can simply say that I less than key dot length. That means the length of the string which we have provided. Your key can be actually anything, but right now let's assume it's Harshal. Okay, so I plus plus. So now we are inside the string. Okay, that means we are traversing this string. Okay, so now what we are going to do is simply we are converting each character to its ASCII value. Okay, ASCII values are what? So I'll just show you if you don't know what is an ASCII value. So we can simply search ASCII values. Okay, so you can see we have a lot of things here. You can go to any website and you might know more about ASCII values. Okay, so let's go to the first website only. So here you can see that, okay, specifically they haven't okay, yeah, they have actually provided this. You can see we can actually write specific capital A as 65, and if I go about small a, you can see small a is 97. Similarly, capital B is 66, small b is 98. So we are actually converting these characters, that is first character will be h will be converted into ASCII value. Okay, now we have converted into ASCII value, and we'll sum all the values together. Okay, sum all the values together. That means ASCII value of h, ASCII value of a, ASCII value of r, we'll sum all of them, okay, in this for loop. Okay, so now we'll simply say we have a hash, and we are actually starting with 0. So this simply means that total will be added up to this number. Okay, something like this. Okay, so now we'll simply say that we are adding the sum all together into this variable. Okay, so we'll simply say key dot, and for finding an ASCII value we simply write char code add, and we'll find the value with that. Okay, we find the value with that. So we are simply finding the character, we are simply finding the ASCII value like this, and we are actually summing all of them with this. Okay, so now a hash contains the sum of all values. So let's see how it actually works. So suppose if I just print sol.log hash, let's see what actually happens here. So I'll be calling this function, and you can see that right now I've just passed a simple word ping, and now you can see the hash table size is 10. Okay, so by the way, its output will be 532. I got the suggestion from GitHub Copilot. So now let's try to run this. Okay, so what I'll do is I'll just go to the terminal, and I'll simply type node script1.js. So now you can see that I am getting 434. So I think it was actually 434. I don't know the exact sum. So you can actually see that we are able to get the sum. Okay, we are able to get the sum and we are able to store that sum. Okay, so I think it's fine. So similarly, let's see what's different for Harshal. Okay, so if I try to get this, you can see it's 739. So you can see that I converted this key into a number. Okay, into a number. And okay, so you can see that we have converted this key into a number. So that's how you can store values also. Now we have converted it into a number. Now we can store this value in the table. Okay, so one more thing, one more important step. Right now I have just shown you what it actually does. We have to make sure that our value which we got actually fits in the table size. Okay, so value is something like 434 and table size is 10. Let's see. Okay, so now if I try to get this, you can see. Okay, I actually need to call this function in a different way. So we'll see that later on. But right now you can see that we actually need to check that the remainder, if the remainder is something else, we'll get the remainder. Okay, so we'll see and it will return something. All right, so we have decided thing, and right now let's say we'll just say that we won't be calling the function. We'll say that the table size const, let's say our table size is 10. Okay, let's assume we are assuming a small table size, but usually it's not that small. Okay, so hash table, and suppose its size is around, let's say it's 10. Okay, let's say it's 10, and then we are also going to create an empty array. Okay, so for storing the values, so hash table equals this, so it will contain all the key value pairs which we will be creating using hash table. Okay, so now we have this blank array, and we have the table size, we have the function. These three things are very important. Now comes the important part. First of all, we need to create an insert function so that we can insert value into that particular hash table. Okay, so how can we do that? We can simply say we have a function. Inside this, we will be inserting the value by simply, we'll just say that our insert function is here. Okay, you can name it any different thing. Okay, inside this, we'll again provide the key and the value. Suppose I want to insert a key named as Harshal, so I'll be giving its key and its value something like this. Okay, suppose the key is um, age. Okay, suppose the key is age, that is age is a string and its value is 25. So both things will come up here. Okay, whenever we call this function. So now inside this, we will get the index by simply providing the key which we got and the hash table size which is 10. Okay, by simply saying that let index. So we'll be creating a unique index here. We'll be creating an index here, and we'll be simply getting it by simply calling the function hash function, providing the key. Suppose the key was age, so age string will be provided and the table size, and in return it's actually returning me the remainder of this. Okay, you can see it's returning me the remainder of this. So let's actually see what's happening here. So I'll just call it console.log index. So we'll see what it actually returns by simply calling this and getting the value. Okay, so now I'll be just calling this. Okay, so what I'll say is insert, and what I'll actually do is, suppose my age, okay, my age is suppose 27. Okay, something like this. So let's see what it actually returns. So now you can see I'm getting 1. Okay, suppose I'll say age 123. What it actually returns is, now you can see 1. It simply means that our value is actually is available in the table size. Okay, so now let's say we'll add a few more values. Let's see what actually happens here. Okay, so now we actually got the index. Okay, we actually got the index. So what we'll do is, we'll simply say, let's call it again. Okay, let's call it again, and this time 1 2 3 4, something like this. Okay, so now you can see first I got 1, then I got 3. Okay, so let's see what's actually happening here. Okay, so we got the index. Now Now we have the index. Okay, so we'll simply say, suppose this time I got 1, okay, but some other value also I can get 1, okay, I can get 1. So it might be a collision. Suppose the old value might have some value. Suppose this index came up to be 25. Suppose 25. Okay, now 25 had value Harshal Jain. Okay, again I called it. Okay, again I got an index of 25, but for some other key. Okay, for some other key. So there might be a collision. Okay, you already have a value in that key, but now you are again getting that and you want to update that key. It's not that possible. Okay, so now we'll simply do is we'll simply detect a collision. Okay, so if collision happens, we'll get an output like so collision has happened, you can perform different tasks. Okay, so we'll see that what is collision actually. So I'll simply say that if hash table index, if it's filled, that means it won't be, okay, I'm sorry, if it's filled, then it won't be undefined, right? It won't be undefined. So what we'll actually do is we'll simply say that if it's not undefined, that means it's filled. Okay, that means we are actually getting an index which is already filled. Okay, so it will actually cause a collision. So we can simply say that if it's filled, we'll simply say that collision is detected. Collision. Okay, you can simply print collision is detected for key, something like this. Okay, so if collision happens, that rarely happens. If you provide a lot of values, when you insert a lot of values, that happens where it will cause a collision. Okay, so now what I'll say is, now we'll be simply saying, right now we are just overwriting the value. Okay, we are just overwriting the value. So if it's a collision, you can actually deal it with this way, but right now we are just overwriting the value. Okay, so here you can see we have just provided that specific index, that value. Okay, that specific index has that value. That means we have actually created an empty array. Okay, suppose its index was 3, so in the third index of this array we have the value of Harshal Jain. Okay, suppose this key was first name. Okay, first name, and the value was Harshal. Okay, so we'll find the index, and in that specific index, which simply depicts what, which simply depicts my first name. Okay, first name, and now value will be stored in that array. Suppose the index was 5, so in the fifth index of this array we'll be having the value Harshal. Okay, so I hope you got the idea why, how are we doing things here. Okay, so now let's try to insert a few things. Let's say insert, and we'll be actually inserting apple. Okay, and it will be having value of, suppose, red. Okay, red apple, and then suppose banana, yellow. Okay, and then suppose we have orange as orange color, so instead of that we can say mango as green, so it's better. So you can see I've provided some key, some value, some key, some value, some key, some value. Okay, so you can see it's happening something like this. So let's try to run this. So you can see I am getting this, but there is a collision for mango. Okay, so there is a collision for mango, so it might happen in a lot of cases. So we can actually deal this with later on, but right now I've just passed the value like this. Okay, I've just passed the value whatever it is into that specific index. Okay, into that specific index. So let's see what's actually happening here. By getting the values, we can actually see what value is available. Okay, so for that, if you want to get the value, okay, you can simply, okay, first of all let's try to print hash table array. Okay, so you can see that we have green, for mango. Okay, then we have an empty, okay, we have empty array, then we have yellow for that. So you can see that something happened here. So that's how you can do things. So for the zeroth index we first had red, I think. Okay, we first had red, then it overwrited by causing a collision, and now again the green went to the zeroth index, so it's actually overwritten, and mango is now having green. Okay, so it's actually depicting mango now. So that's how you can do things, and we'll see that how we'll be dealing with collisions. Right now we have just overwritten apple with a mango. Okay, because both of them had the same index. Okay, there can be a lot of cases because some can be same. Here we are just getting the sum. Okay, we are just getting the sum, so some can be same, so there are a lot of cases like that. Okay, So now let's continue. We are trying to get the values. Okay, we can actually get the values in also other manner. We got the value in using hash table, calling the hash table, but we can actually get the value by simply saying console.log. Inside this, you can say hash table. Okay, hash table. Inside this, if you want to get the index, okay, where is the hash table? Okay, so we have given it a wrong spelling, so let's give it a hash table. Okay, fine. So now inside this we need to just provide the index. Okay, how can we provide the index? By simply giving the index. Okay, by simply giving the values. So here for getting the index, I simply say hash function. Inside this you can simply provide the hash table size and also the value which you want to get. Okay, so now let's see what it gives. So you can see it's not giving me red now, it's actually giving me green now, because first it's detecting that the index for this was 0, and what's in 0, green is actually in 0, not red is in 0. Okay, so I hope you got the logic what's actually happening here in this specific case, that we are overwriting things. We are not dealing with collisions, we're just detecting the collision. If we'll in future we'll see that if there is collision we'll change the index, something like this, but right now we are just overwriting things. Okay, that means even if we had apple at first, still if we got the same index for mango, it will be overwritten. Okay, so now we have mango and green. So now you can see that we got the same for you can get the same for banana. So if I just comment this out, and I'll get that banana is actually having this. Okay, so now it will work. Okay, so you can see banana is actually giving me yellow. Okay, so I think that this is a little bit of basic of hash table. Okay, this is just a basic of hash table. There are actually a lot of things which you can do with hash table. So suppose right now you can see we have overwritten this collision. How we can actually deal with this collision? So there are actually two methods. One is separate chaining and second is open addressing. So we'll see both of these methods so that we get a better idea what's actually suitable for us. Okay, so these concepts might sound difficult, but they're actually easier. Okay, they are actually easier. So right now we'll just comment these out. Then what we'll do is in the next line, we can simply say, first, let's see what is separate chaining. Okay, so in separate chaining, collisions are handled by creating arrays or other data structure each at each hash table index. That means uh, if you detect a collision, you create a new array inside that. Okay, you store both the values, something like this. Okay, so suppose we got the collision for apple and mango. So what we'll do is we'll we'll create an array at 0th index and we'll be storing both the values. Okay, so let's see. So here what we'll do is we'll simply say, again we have let hash equals 0. The function is same, and I'll just tell you what are the changes here. So you can see that this function will be same because we are converting things, and then you can see that the size is right now again 10, but right now instead of this I can actually create an empty array so of hash table size, because I don't think that we can use this approach also by defining the table size. Okay, so suppose now the array is of length 10. Okay, so now what we'll do is we can actually insert the values. So we have the insert function here. Okay, till now it's fine, but when we have a collision, okay, when we have a collision, we need to deal with that. Okay, so just don't just wait for the collision. What we'll do is we'll just say that if that specific index which we are trying to which we got is empty, so what we'll do is we'll be creating an array inside that. Okay, so so you can say that each index now will be having an array inside that. Okay, so suppose the 0th index is here, we'll be having an array available in 0th index. First index we will having an array in first index, something like this. Okay, so we'll be having an array at all indexes, something like that. Okay, so what we'll do is if that hash table index is actually undefined, then what do you need to do is you need to just create an empty array. Okay, so we'll be just creating an empty array into that specific index. Okay, into that specific index. So how can we do that? hash table, and we simply did was we simply created an empty array inside that index. Okay, so now what actually happens is, suppose I am starting with 0th index. 0th index will be initially empty, so what we'll do is we'll be creating an array inside that 0th index. Okay, we'll be creating an array at that first index, second index, third index, up to the length of the array. So each index now will be having an array. Okay, so now what I'll do is, how can we push things here? So since it is an array, now we can provide multiple values to a single index, right? Because since it's an array, okay, so apple will also be stored and mango will also be stored, because we now have an array. In an array we can provide multiple values. Okay, so now what we'll do is we'll simply say that hash table dot index hash table, in that particular index we will be pushing our key value pair, something like this. Okay, so you can push your key value pair something like this. We will actually make it an object, it would be better, I think. So provide it as an object. So what will happen is, in the 0th index we'll be having two objects now. First is the apple, second is the mango, something like this. Okay, so now let's try to add the values again. So this is also called a good approach for adding values. So now you have added values apple, banana, mango. Okay, so now let's see what happens in the hash table. So if we try to run this, you can actually see that the 0th index has now two values. Okay, now has two values, but all the values are preserved now, and you can see that banana has one value. Okay, so we have actually categorized them accordingly to the indexes which we got. Okay, so in the 0th index we have two values. We can actually have a lot of values like this because we have created an empty array. We can increase the length also very easily in JavaScript. So you can see we handled the collision very easily. Now there is no collision between these two, both of them are available. Okay, so this was the first method, which is known as separate chaining. Okay, now we have second method named as open addressing. So let's see what the second method does. So what I'll do is I'll be just copying this whole code. Okay, so we'll create another file. So script 2.js. Okay, so we'll be pasting it. So now we'll be working on this so that that code is preserved. Okay, so now what we'll do is we'll be working on open addressing. So what actually open addressing does is, in open addressing, collisions are handled by finding alternative slots. That means if this index is filled, we can actually find some other index. Okay, it will happen something like this. So this is also called as probing. Okay, probing. I think I'm pronouncing it incorrect, but it's known as probing or probing. Okay, so within the hash table, to store the colliding key value pairs, we find a different index. Suppose the 0th index is already filled for the previous case. Okay, for the previous case where we just ignored the collision. Okay, for the first case, right now we have just created an array, but before that we were ignoring the collisions. We were ignoring the collision by this. Okay, and then we were overwriting the values. But suppose we don't want to override the values, we don't want to create arrays, then what can we do? We can find some other index, okay, some other home to stay. All right, and if some other person comes, then they can find some other home if index is same. Okay, so what can we do is we can simply, first of all, it's the same for the hash function. We have the same hash function here. Then I think that it will work. Hash table size is 10 and we have created an array of size 10. Okay, you can actually create an empty array also. There is no boundation with this. Okay, so now we have created an insert function here. Inside the insert function, this was clear. Okay, we got the specific index. Now what to do with the index? So I'll simply say that if it is not undefined, okay, so what I'll simply say is we'll simply find a new index until we find an undefined index. Okay, we'll simply find a new index by simply calling a while loop. Okay, inside a while loop I'll say that the home which I'm looking at is empty. No, it's not empty. So I'll look into the next home. It's empty. No, it's not empty. I'll look into the next home. It's empty. Yes, it is empty. So I'll stay in that home. So now if some other person comes, he'll find the home and will go to the empty home, something like this. Okay, so I'll simply say while inside this, I'll just say hash table index is, if the index is undefined, we'll be simply incrementing the index like this. Okay, we'll be simply incrementing the index like this. So I hope you are understanding it. And now we have incremented it, but yeah, one more thing, we actually need to write it in a different way. So I'll just simply say that the index must be actually in the table. Okay, inside the table. That means if the index is currently 10, okay, and the size of our table is 10, the index must not be 11. Okay, I hope you are getting this. So how can we deal this? We can simply say index plus 1 and it must be inside the table size. That's it. Okay, so now we are actually finding that index which is empty. Okay, it is empty. Which is not empty will be ignored like this. Okay, so we'll be just incrementing it. Once we find an index which is undefined, which value is not defined, then we'll say, yeah, this is empty, I can stay at this home. Okay, so now we have that index because we have changed the value. Okay, so now we have that index which is available. So this is also known as linear probing because we are actually doing this linearly. Okay, so now since we have that index, we'll simply provide the value. That's it. We'll simply provide the value. So this is the insert function for the second type, that is open addressing. So I hope you got the difference between both the types of collisions. So you can see that again I have passed three values: apple, banana, mango. So let's see what actually happens with these. So now you can actually see that, okay, I just ran the wrong one. So now you can actually see that first we try to find that in the first case you could have just that, yeah, uh, index of apple and mango were same, both were same. So mango had overwritten apple. Okay, if you saw the first part, you can actually judge that it had overwritten, but in this case it had actually shifted mango to the next index, to the next index. So what it actually did was, it didn't overwrite it, it actually shifted that to the next index. So again we have all the values, but now we actually found the next index which was empty. Okay, if suppose the first index was empty, wasn't empty, then we would have gone to the second index. Okay, so if zeroth index wasn't empty, if first index wasn't empty, then we would have gone to the second index, something like this. Okay, and it will happen till when? Till the size of the array. That means if the size is 10, okay, and if we have one more item to be filled, if the array is filled, then we can't do that. Okay, something like this. Okay, so I hope you got the idea. But usually the table size is not given this way. They usually judge what can be the actual size, then this provide the size. Okay, so it's not too easy to provide a table size. This is also complicated job. Okay, all right, so I hope you got the difference and why are we using hash tables. So what are actually the limitations of hash tables? So the limitation of hash table is number one, memory usage. So hash tables are required to use additional memory. As you can see that we are just providing tables on and on, so it's actually using a lot of memory. Again, there are potential for collisions. You can see that collisions were happening, but we dealt with the collision. But in a larger scale, it becomes very difficult to deal with the collisions because since there is a lot of data, so there is a potential bit for collisions. Okay, number three is trade-off between memory or lookup speed. So there is a trade-off between memory usage and lookup speed in hash table. As the table size increases, to reduce collision, more memory is used. Okay, so to get fast and efficient data, we are actually increasing the table size. Okay, we can increase the table size obviously, so more memory will be required. Okay, so also we are dependent on hash function. Which sometimes give similar values. So this is also a drawback for that. And these were some limitations of using a hash table. But apart from these, you can actually get the values. Obviously you want to get the values, you'll be getting it in this way. So you can see we actually got the values very easily for the hash table. Okay, by simply calling that, yeah, I want to get the value of apple, I got the value of apple, something like this. Okay, so if I want to test this again, okay, if I want to test this again, and let me just comment this out. Okay, so now if I want to get these two values, so let's see. So now you can see I got the value of apple, value red, and banana as yellow. So you can see that it's working fine. Similarly, I can get for mango also. So you can see I got the value of apple, banana. Okay, so yeah, in this case also you can see that this is also a very big problem. So why it happened? So here you can see that I was trying to get the value of mango. Okay, I was trying to get the value of mango. What it actually did was, if you try to get the value of mango this way, so it will actually cause a problem. Okay, so for retrieving the values for this case, we'll actually do one more thing. We'll simply say that const index equals, okay, so suppose you want to get the index of apple in this case. Okay, so it will give you 0. Okay, so first we have the index, then we'll simply say const we'll again create a variable named as pair. Okay, we'll again get the value as pair. So now you can see that if both of them match, then we'll get the value. Okay, if both of them match, then we'll get the value. So I'll simply say that if my tables key matches with this, okay, with this, so we'll simply say, and one more thing, my pair, if pair existed, then we'll be seeing that my tables key matches with this, then I'll get that. Okay, I'll get that. Okay, so I'll get that value. So suppose if I try to get this, you can see I got red. Okay, so suppose if I say that this time I want for mango. Okay, mango, let's see what happens. So you can see that for mango I didn't get anything, because on the 0th index we don't have mango, we have apple, right? So that's how you can get things. And definitely it's a more broader concept. You can actually address these values by calling it separately. You can perform search operations inside this array, because we, since obviously it's an array, okay, array inside array, and we are actually creating an array. So you can use a simple for loop or different kind of loops to perform searching operations that way also. All right, so I hope you understood this. If you want to get the value, this is a very basic method, but instead of that you can perform searching operation which are available in algorithms. Okay, that is binary search, linear search, something like that. Okay, so you can learn that while learning algorithms. All right, so I hope you understood the concepts of hashing. That is what is hashing, why do we use it instead of objects, what are different kind of collisions, and how to deal with them. All right, so I hope you understood the concept of hashing. And hi Ritvik, how are you? And if you have any doubts, then you can definitely ask me right now. So before ending this video, in the live chat, you can see that we have a link which is for a course provided by Geeks for Geeks. It is actually a course for data structures and algorithms in JavaScript. Okay, so if you visit that link, the link is also available in the description. So if you visit that link, it will take you to a specific page, and here you can see that you need to log in for registering for access of this course. Okay, so if you want the access of this course, and this is a paid course, so you need to purchase it. And you can see that we have a lot of topics covered here, including data structures and algorithms in JavaScript. And it also includes some basics like mathematics, which is required, bit magic, and a lot of basic things. All right, so you can see that if you want to learn things from basics to advanced, do follow this one, and you can purchase this course if you want. All right. All right, so I hope you understood this video, and I don't think anyone has any doubts right now. So if you have any doubts, you can message me on Instagram at the rate Harshal Jain. Okay, at the rate Harshal underscore 3011. You can message me here, or you can search me on LinkedIn. Harshal Jain is my name. All right, so that's it for today. I will see you in the next one. Till this, have a good day. Bye bye.